Hello, class. In this video, we're going to look at writing equations for lines that are parallel or perpendicular to a given line. So given this note structure setup, I'm going to go ahead and I'm going to skip the opener for today since that was basically the same thing we did in the closer the other day. I'm going to do example 1, I'm going to do example 2, and then I'll do example 3. I'll leave the you-dos for you to enter in your answers as you go, and then I will leave the exit ticket. You don't actually have to turn in a paper exit ticket for this one. Just go ahead and type in. There will be a prompt at the end that you'll type your answers in. Okay. All right. So let's begin with example 1. We got a line that passes through 12, 5 and is parallel to the graph y equals 2/3 x minus 1. What equation represents the line in point slope form? So the first thing we're going to need there we go. We're going to need our point slope form. Okay. Now, when we're thinking parallel lines, we think back to the lesson the other day. We're talking about lines that will have equal slopes. So that means my m is 2/3. Okay. And my point x1, y1 is 12, 5. So we're going to start y minus 5 equals 2/3 x minus 12. Okay. But they want it in slope intercept form, which means we got to do our two-step process. We're going to distribute. We get y minus 5 equals 2/3 x. 2/3 times 12. Well, that'd be 2 times 12 is 24 divided by 3 is 8. And then we're going to add 5. And we get y equals 2/3 x. Negative 8 plus 5 is negative 3. And so that will be our answer for this problem. Okay. So like I said, a prompt will come up. Go ahead and do the you do, and then check back for a solution. Okay, so let's go ahead and do example 2. A line that passes through 2, 4 and is perpendicular to the graph y equals 1/3 x minus 1. What represents the line in slope intercept form? So now we're perpendicular. So we got to remember our two words for perpendicular. That's opposite reciprocal. So 1/3, the opposite of a positive would be a negative. And then the reciprocal of 1/3 would be 3/1, or just negative 3. So let's write out our general form again. So y minus y1 equals m times x minus x1. Okay. So we got x1, y1. So that's y minus 4 is equal to negative 3 times x. Sorry, having little trouble. There we go. And now we go ahead and do our two-step process again. So we'll distribute. There we go. We got y negative 3x. That's a negative 3 times a negative 2, so that would be a plus 6. And then we'll add 4. We get y equals negative 3x plus 10. Okay, so let's take note so far. We're not really doing anything new. We talked about slope of parallel and perpendicular lines the other day. Slopes will always be equal, for parallel lines, and then for perpendiculars, it's opposite reciprocal. But writing equations out in point slope form and then transitioning them to slope intercept form is something we've done many a times. Okay, so go ahead and do the you do, and then check back for an answer. All right, so example 3, a line that passes through 4, 6 and is perpendicular to the graph of y equals -3. What equation represents the line? Notice I don't say in slope-intercept form this time. Let's note why. Y equals -3 is a horizontal line. Horizontal. Okay. That means if we're looking for perpendicular, we want a vertical line. Okay. Now, vertical lines will always come in the form x equals. Okay, so x equals what? We need a number. Vertical lines are always in the form x equals a number. So let's look at the point. That's also our other given information. Our given information is 4, 6. That would be our x1, y1 value, how we normally label that. But since we just want a vertical line, we just want that x value. So that would be x equals 4. If I wanted a horizontal line, it would be y equals 6. And that's how we determine vertical and horizontal lines from a given criteria.